Hi everyone, myself Ramesh Kumar. We group 8 from GM University are here to present our project titled Healthcare Chatbot. This project was guided by Mr. Vinay HS from the Department of ISC. Our team members are Kirtanavi, Manasa KG, Muhammad Fujail Hamid. Contents are introduction, features implemented, system design, algorithm, output, overview, future scope, conclusion. Introduction, healthcare chatbot is an AI powered system that interacts with users using natural language processing. It uses natural language processing to understand and respond to health-related queries. Users can get real-time response to common symptoms, book an appointment with a hospital, find nearby clinics, access frequently asked questions based on knowledge. It is available 24 by 7 and works like a basic digital assistant, reducing the load on healthcare staff by answering frequent repetitive questions and guiding patients to proper care. Next, features implemented. We implement the following features in our chatbot using Python and Tinter, secure login system, email and password verification to ensure only authorized access, smart chatbot response to 18 plus predefined symptoms using natural language with basic diagnosis and suggestions, frequently asked to tab, a quick access database of health related questions and answers that educates users, appointment booking. Users can enter their name, date, hospital, and reason. The system checks the format and validates entries. Hospital into now information tab displays a list of nearby hospitals and clinics with their names and general information. Users friendly interface, Bully using enter to make the navigation initiative and pleasant for users. Thank you. Further will be continued by Manasa.
I'm Manasa KG. I'm here to explain about system design and architecture and flowchart of our project. Front end Tkinder GUI, next login page, next dashboard, and next chatbot tabs. This is the graphical user interface created using Tkinder. It is a built-in Python library. The system starts with a login page where users enter their credentials. Once authenticated, they are directed to a dashboard that acts as a home screen. From the dashboard, users can navigate through multiple tabs such as chatbot, frequently asked questions, appointment booking, and hospital information. Next, chatbot engine. This is the core logic of the healthcare assisted written in Python. It takes user input, which is symptoms, matches it with known conditions. Then it generates responses such as possible diagnosis or advice. Uses simple if else or keyword matching techniques or even natural language processing methods to understand and reply. Next, frequently asked questions database, a hard coded list or dictionary in Python containing frequently asked questions and their respective answers. A tab gives user quick answers to common health questions without needing real time processing. Appointment schedule. This part handles form based input from the users to schedule an appointment. This typically asks for name, date of visit, reason for visit, and selected hospitals. The system checks for valid inputs like correct date format and may show a confirmation message like pop-up message in the output. Next, hospital information, a static list of nearby hospitals, possibly hard coded or stored in a file. Each hospital entry may include name, address, contact number, and specialist. Displayed under a dedicated tab of users to browse a choose duration appointment scheduling. Next, flowchart. Uh, Flowchart. This is the start. This is an entry point of the application. Next, user opens login page. The user starts by opening the login page. This is likely a simple which users enters inputs and login id or a password. Like this marks beginning of the application process. Next, the user opens the login page, which is mostly like to be an web interface which is in Python. Next, user enters an email and password. The user inputs their email and password to authenticate themselves. Next, to validate inputs and login. The inputs, email, and password are sent to a Python backend script. This script validates the credentials. Example, checks if the mail and password matches the stored user. Next, Flask launches tkinder GUI dashboard.py. It is upon successful login, Flask or a backend service triggers the main application and tkinder GUI builds and dashboard. This opens a new window for the user to interact with. Next, user select one of the four options. In the tkinder dashboard, the user sees four different options such as chatbot, FAQs, and appointment. Next, hospital information. Just click one to proceed. Next, chatbot. If the user select the chatbot tab, they are directed to the chatbot interface. Next, enter symptoms. The user is prompted to a type in symptoms. Example, left leg or right leg pain, and etc. Chatbot responds based on keyword. The system uses keyboard matching or logic to analyze the symptoms, then it provides a relevant response or advice. Example, you may be experiencing a viral fever, stay hydrated. Like this. FAQs, if the user chooses an FAQs tab, they move a screen showing commonly asked questions. Next, show predefined medical question and answers. The FAQ section displays a static list of questions and answers about health topic. Example, what is diabetic, how to treat a cold. Further, it will be explained by Fuzel.
Myself Mohammad Fuzel and I am going to explain the algorithm. First is login validation. Input email and password. Then if valid it opens the dashboard. Means the system checks if the entered email and password match the hard-coded credentials. If valid the dashboard is opened for the user. Next is dashboard navigation. Buttons direct to chatbot or FAQ or appointment or hospital. Users choose from chatbot if he wants to ask the questions or if he wants to take an appointment and or want to get the hospital information. You can use the buttons to access that. Next is chatbot processing. Get user input, lowercase it, check for symptom match, output diagnosis, and advice. Means user input is first converted to lowercase for consistency, then it is matched against a list of known symptoms. If a match is found, a predefined message is displayed. If not, a generic response is given or the user is redirected to the appointment tab. Next is appointment booking. Validate fields and date format. If valid, confirm booking with message. Means input fields like name, reason, hospital and date are validated. Once successful validation, a confirmation message is shown. Here you can see this is our code. After running this code, after running this code, we get an output like this. This is an interface after running our code, which shows the welcome user and ask to enter the email and password. After entering the email and password, a login successful pop-up will shown as telling welcome. After that, uh, we came to uh, we came to our healthcare chatbot where we can chat with chatbot or ask the questions, medical information, and take appointment booking and also check the nearby clinics and hospital. If we click on the chat with chatbot, an interface like this will open where we can ask what problem we have. Chatbot will answer for that. Here, if we give the input as left leg pain, the our bot will reply and give advice for that. Next, for example, again if we type the chest pain, it will give another advice for that. And if you want to contact the doctor, If we give this input, it will tell us to go to the appointment tab. Here it is our appointment tab. First, it asks the full name of ours and then the date when we want an appointment. Next, what's the reason? At last, we have to select in which hospital we want that appointment. After giving submit, appointment booked pop-up will be shown. Further will be continued by Kirtana.
Now that we have seen the working of our chatbot, let's take a step back and look at the overall picture and where this project could go in the future. Our chatbot is already capable of handling basic interactions, answering symptom related queries, and managing appointments. However, with emerging technologies and increased user demands, we see several opportunities for expanding its capabilities even further. It add emergency support features for critical conditions, and it enables multilingual conversations using external APIs for regional language support, and integrate hospital database to fetch real-time availability or doctor information. And it also connects with wearable devices to monitor parameters like heart rate or temperature. And it uses machine learning to train the bot on real world user queries and improve response quality over time. This evolution can turn the chatbot from a basic assistant into a fully operational healthcare companion. And to sum up our conclusion slide, to sum up, our healthcare chatbot provides a smart, fast, and accessible solution to manage basic healthcare queries, and it also reduces pressure on medical staff, works round the clock, and serves as a reliable first level assistant to patients. And it's a significant step toward a digital, intelligent healthcare future where users can access primary care anytime, anywhere. Finally, we believe this project has the potential to be developed further and contribute to real world healthcare systems with proper integration and advancement. And with that, we come to the end of our presentation. Thank you.